So in this example for poker hands, it states, in 5-card stud poker, a full house is a hand that contains 3 matching cards of one rank, and a rank is a value of the card, such as a 2, 3, 4, etc., all the way up to an ace, and 2 matching cards of another rank. If you are dealt 5 cards, and then we have these 4 questions here. So A, it says, determine the different number of ways of being dealt a full house from a well-shuffled deck that consists of 3 kings and 2 queens. Now, keep in mind that these examples are designed to get the student to think clearly. So accompanying this example is a graphic of a deck of playing cards within the lesson that shows the different playing cards by rank and suit. So we want to get 3 kings and 2 queens. So there are 4 kings and there are 4 queens, and they're broken up by their suit. And the suits are, I'm just going to write it right here. You can have a spade, a club, a heart, or a diamond. So what I'm going to do is I'm just going to simply make the sample space for getting 3 kings. So I'll put it right here. How about if I mark this as kings? And you can get a king of spades, a king of clubs, and a king of hearts. Or you can get a king of spades, a king of clubs, and a king of diamonds. A king of spades, a king of hearts, and a king of diamonds. Or you can get a king of clubs, king of hearts, and a king of diamonds. So that's the sample space. This can also be determined as 4 choose 3, and 4 choose 3 is 1, 2, 3, 4, comes out to be 4. So there's 4 different ways that I can be dealt 3 kings. For the queens, we'll do the same thing, except we want 2 queens. So I'll make the sample space here, put in my queens. You can be dealt a queen of spades and then a queen of clubs, queen of spades and then a queen of hearts, queen of spades and then a queen of diamonds, queen of clubs and then a queen of hearts, right? Clubs and then diamonds, and then a queen of hearts, and then a queen of diamonds. There's 1, 2, 3, 4, 5, 6. That's also 4 choose 2, 4 queens, and we want 2 of them. 4 choose 2, so that comes out to be 6. And of course, since we want our hand, when we're dealt our 5 cards, we want 3 kings and 2 queens. How many ways can that happen altogether? Of course, the fundamental counting principles says, just go ahead and multiply 4 times 6. That's 24. So there are 24 different ways you can be dealt 3 kings and 2 queens. For B, if you are dealt 5 cards, determine the different number of ways of being dealt a full house from a well-shuffled deck that consists of 3 cards of one rank and 2 cards of another rank. So for A, we want our cards to be 3 kings and 2 queens. But for B, they could be anything. They don't have to be kings and queens. They can, but they could be anything. So it's still going to be one of these setups for 3 of the cards and one of these setups for 2 of the cards. So how many different ranks are there? Well, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, and an ace. There's 13 different ranks. So this can be any one of those ranks. But rather than it being just kings, it can be anyone. For here, this can be any other rank. So whatever rank this is, there's 12 left for this one. So I'm just going to put down 12 here. So now rather than have 4 times 6, I'm going to have 4 times 13 times 6 times 12. Well, 4 times 6, that's 24. Then I'm just going to multiply this by 13 and multiply this by 12. Or you can have 4 choose 3 times 13 and 4 choose 2 times 12. Either way, we're going to have 24 times 13 times 12. There's 3,744 different ways we can be dealt 3 cards of one rank and 2 cards of another. Now C says, what is the probability of being dealt from a well-shuffled deck any full house? Well, there's 3,744 different ways of being dealt a full house. So what's the probability of that occurring? So of course we know that A over B, A is our event. That's what this is, the 3,744. We want B, and of course B is the size of our sample space. Well, what is that? Well, how many different ways can we be dealt 5 cards out of 52 playing cards? Well, that's going to be 52, choose 5. There's 52 choose 5 different ways of being dealt 5 cards. That's our sample space. What's the probability of getting this? Well, that's 3,744 out of 52 choose 5. And of course, that's exactly how I'll put it in my calculator. 3,744. Just hit divide. 52, back to my probability key. Choose 5. So that's approximately 0.0014. And of course, we recognize that as 0.14%. The same idea for D. What is the probability of being dealt from a well-shuffled deck a full house that consists of 3 kings and 2 queens? And of course, there's only 24 ways for that to happen. So that's 24 out of the 52 choose 5. So we'll do 24. Divide that by 52. Choose 5. And that's approximately 0.000092. Now I know we've done 4 decimals as a decimal, but if we rounded that to 4 decimals, that would come out to be 0%, no probability, and we know that's not the case. So we'll just go ahead and go to these points down here, and of course we recognize that 0.00092%, very, very small. And there we go.